So as I told you in the previous video that exponential functions do occur in calculating compound interest. Suppose if you are investing a principal amount P over a period of time I, okay, then after the one period the interest is Pi. So this is the interest, and the amount A at the end of one period would be P plus Pi, right? So that is nothing but P times 1 plus I. So if the period increases, like for the second period, it would be like P plus Pi or P plus 1 plus I the whole square. So after the second period, it would be, the amount would be A is equal to P times 1 plus I the whole square. So after K periods, so we see that A will be equal to P plus 1 plus I whole power K. So you can clearly see an exponential function in the form of 1 plus I whole power K. Correct? So where the base is 1 plus I. Correct? So if the annual interest rate is R, so if R is the interest rate, and if the interest is compounded n times a year, so this is the number of times the interest is compounded, then in each time period the interest rate I, the rate would be R divided by n. Correct? And there are nt time periods in T years. So this leads to the formula that for amount in after T years. So that is your compound interest. So the compound interest formula is calculated by the formula A is equal to, A of t, this is a function, A of t is equal to P times 1 plus R by n whole to the power of nt, where this A of t is nothing but amount after t years, after 3 years, okay, and P is the principal amount, okay, and R is rate of interest rate per year, and n is number of times interest is compounded per year, that I wrote it above here, and t is number of years, so t would be number of years. Okay, using this formula we will be able to find out the final amount after a certain period of time. And here R is referred to as nominal annual interest rate. So R is also referred to as nominal annual interest rate. So it is for 1 year. Okay, suppose if I am given, and let us do an example. Suppose there is a sum of like $1,000. Okay, $1,000 is invested at an interest rate of 12% per year. 12% per year in the sense this is P, okay, and R is 12% per year in the sense 0.12, okay, and find the amount in the account after 3 years. I'm sorry. So time is 3 years. Okay, time is 3 years. So we have to find the amount in the account after 3 years. If we compound the interest annually and semi-annually, quarterly, monthly, and as well as daily. Okay, so we use the formula to calculate this. But how do we do that? So if we are compounding annually, so what is our n? That is the number of times the interest is compounded per year would be 1 time, right? So it is 1. N is 1. So what happens to the formula A of t? A of t would be 1000. 1 plus r is 0.12 divided by n is 1, correct? So 0.12 divided by 1 whole to the power of nt. Nt is 1, 3. So 3. So this would give us, upon calculation, this would give us $1,404.93. Okay. So if we are calculating semi-annually, that is 6 months once, so that would be twice, correct? So twice in a year, the interest is compounded twice in a year. So n would be 2. So if you apply the formula, it would be 1000 plus 1 plus, times 1 plus 0.12 divided by 2 whole to the power of 6. So this would be 1418.52 for every 6 months. So if it is quarterly, it is 4 times an year, correct? So for every quarter of an year, so 4 times an year. So if you apply the formula, you will get it to be 1425, yeah, 0.76. And if it is monthly, so there are 12 months in a year, so the number of times the interest is compounded is 12 times. So applying the formula, like substitute 12 in the place of n wherever you have n in the formula, so you'll get it to be 1430.77. and if it is daily, it is if it is daily, it is 365 days a year. So that would be something amounts to 1433.24 per day. Okay, so if an investment earns compound interest, then you can see that if it the number of it totally depends on the number of times the interest is compounded. So the more the number of times it is compounded, the more the growth you can see in the amount invested. Okay, and if an investment earns compound interest, then the annual percentage yield, that is APY, which is called as annual percentage yield, okay, is the simple interest rate that yields the same amount at the end of 1 year. Okay, it's that simple interest rate that yields the same amount at the end of 1 year. So like if we are asked to calculate the annual percentage yield, so APY, find the annual percentage yield for an investment that earns interest rate at a rate of 6% per year. So if you are asked to calculate 6% per year and it is compounded daily, then you have to solve for so let us see, we have to find out what is our P, that is the principal amount, the amount for which we will or A. Okay, so this is nothing but P times 1 plus R by N whole to the power of NT, right? So we do not know what is the principal amount, but we know the rate of interest, that is 6% per year will give you 0.06 divided by, so you have to compound daily, so it is given as compound daily, so n is 365, and it is for 1 year, so this the power nt would also be 365. So this is nothing but p times 1.06183. Okay, this is the formula. So now the formula for simple interest, we know what is the formula for simple interest, that is p times 1 plus r. Correct. Now if we see the if we compare the two formulas, we see that 1 plus r is nothing but 1.06183. correct. So r will be 1 minus 1.06183, that would be, oh sorry, so it would be 0.06183. so this is the annual, so that means the rate of percentage is 6.183%. okay, so that is the annual percentage yield. This is the APY. okay, so now for quiz 4.1.3, so do problem number 64. And also problem number 62. So I don't know why I go in the reverse direction always, so I'll write the smaller number first. So problem number 62 and problem number 64. So I'll stop this video here. This is the end of the section 4.1. In section 4.2 we will study about natural exponential functions. So we will see what are the natural exponential function, that is to base e, which is a irrational number. So e is approximately equal to some 2.718 something, and if you raise e to the power of some number, so that is definitely an exponential function. So that is called as a natural exponential function. We will see how does the graphs looks like. We will analyze graphs, and we will do transformations, and we also find out like what is the role of the natural exponential function in compound interest, in calculating compound interest. Okay, see you soon in the next video. Thank you for listening.